Hi guys, welcome to this page of the notes, and again what we're doing is we're graphing radical functions, and now we're going to begin to take a look at this idea of transformations, which we've already talked about back in chapter 2. We're just now going to add another function to the group that we already know, right? We already know the quadratic function, we already know the absolute value function, we know the identity function, we know the constant function, right? Those were the ones we got back in chapter 2. We're now going to add this new one, the radical function or the square root function. And you should recognize this general formula for transformations where the plus or minus a is out front. The h is going to be underneath the radical with the x, and then the k will be tacked on the end. You should remember what each of these does. H is the horizontal shift, that's left or right. But remember, if h is positive, you'll go in the negative direction, and if h is negative, you'll go in the positive direction. You have to remember to switch. Whatever the value of h is, you go the opposite. K is the vertical shift, that's up or down, and it works exactly the way you would expect it to. If k is positive, you go up. If k is negative, you go down. And then A does two things. A is both a reflection across the x-axis. So if A is a positive number, then your graph will be going up. If A is a negative number, then your radical function will be going down below the x-axis. And then also A acts as a vertical stretch or shrink. Vertical stretch or shrink, and remember the way that works. If A is a whole number, a number greater than 1, it's going to be a vertical stretch, right? It's going to make that radical function go down real deep, right? It's going to make it real steep. If A is a number between 0 and 1, if it's a fraction or a decimal, right, then that is going to vertically shrink or vertically compress your graph. It's going to make that radical function real shallow, right? It's not going to have a real steep arc to it. It's going to be a real shallow arc. So we'll take a look and watch out for all of those as we do this next example problem, which I've given to you right here. Y equals the square root of x minus 2 plus 5. Let's go ahead and identify our A, our H, and our K. All right, I know that A is going to be equal to what's out front, which in this case is a plus 1. That tells me two things. First, it tells me that my radical function is going to be opening up above the x-axis. It also tells me that it's just a standard radical function. It's not super steep. It's not super shallow. It's just going to be your standard radical function. I know that the h is what's underneath the radical with the x, and so my h is going to be a minus 2. But I know that that means it goes the opposite direction, so I'm actually going to be shifting to the right 2 units in the positive direction. So 2 units positive. And my k is whatever's tacked on at the back, which in this case is a 5. Since it's a positive 5, I know that means my graph is going to shift up 5 units. All right, so let's go ahead and graph our starting point. The parent function starts at 0, 0, just like all of them do. And I know that I need to go positive 2 units, 1, 2, and up 5. 1, 2, 3, 4, 5. And that's where my radical function is going to start. Up over 2 and up 5. That's going to be my starting point. Now, to find the rest of the points that you need to graph this function, you're still going to need to set up that x, y table. So here we go. All right. In my xy table, I know that my starting point was x equals 2, y equals 5. And let's talk about the reason why. If I plug a 2, right, based on this information, I know that my starting point was 2, 5, and here's the reason why. If I plug a 2 into my function, 2 minus 2 is 0. The square root of 0 is 0. 0 plus 5 is 5. So that's why this is my starting point. Let's find the next one. My next perfect square is a 1. So I need to figure out how to get a 1 underneath the radical. X minus 2 equals 1, right? Well, just simply subtract the negative 2 to the other side and you get x equals 3. So if I plug in a 3, 3 minus 2 is 1, square root of 1 is 1. 1 plus 5 is 6. Next, My next perfect square is 4. So I need to figure out how to get a 4 underneath of this radical. And actually, it turns out that if you set it equal to 4, subtract 2 or add 2 to the other side, you get 6. So if I plug in a 6, 6 minus 2 is a 4. The square root of 4 is 2. And 2 plus 5 is 7. I think we might be able to find one more. We're going to do the 9. My next perfect square is 9. So I add 2 to the other side. 9 plus 2 would be an 11. So if I plug in an 11, I know that that's a little bit off my coordinate plane, but it's not far. I can squeeze it in there. If I plug in an 11, 11 minus 2 is 9. Square root of 9 is 3. And 3 plus 5 is 8. Let's go ahead and graph those points. I've already graphed 2, 5. I got that from the transformations A, H, and K. My next one is 3, 6. 3, 6. After that, I have 6, 7. And after that, I have 11, 8, which is going to be just off my coordinate plane a little bit, right about there. Connect those points with a line, knowing that that is my starting point. And so when I graph the radical function, I get something that looks like that. Again, I used A, H, and K to find me that starting point instead of having to do the whole set x minus 2 greater than or equal to 0 and eliminate domain values that way. I just use the transformations to find that starting point and then fill out my table from there. Head on over to the next page of notes and we'll try another one just like this where we get started with transformations and work from there. So I'll meet you guys on that page.